There is one thing we have not done with vectors yet. What have we not yet done with vectors?
Scalar dot product.
No. Think about it. What do we do with all of our mathematical objects? Ray's done it with two extra kinds of mathematics. He's done it with matrices and complex numbers. We multiply by scalars. We add them. We subtract them.
Divide them.
Square root them.
Before you can divide them, you have to
Square them.
Flip them.
Multiply them.
multiply them.
Oh.
What does it
No,
mean
just
to multiply one vector by another? What does it mean to multiply two vectors?
I don't know.
Wow, my voice is really going.
Oh, we've already
What might it mean to multiply two vectors?
To multiply them, like to multiply them.
Okay, here's a vector. Oopsie. And here's a vector.
Are you going to go to numbers for those vectors?
No. What does it mean to multiply them together?
A times B.
What does that mean?
How many sets of A's are a B? A sets of B.
But they're different directions. How do I multiply them? Is the direction relevant to the multiplying?
Probably.
So I need to come up with some way to multiply them. Now you learned a way to multiply complex numbers.
Yeah.
Do you remember what that was? It's not the same as vectors, but do you remember what it was?
Fives. Do you mean?
Yeah, with complex numbers. How do I multiply two complex numbers? If you think of a complex number as a vector, what would it mean to multiply them? Do you remember? We did talk about this. You don't remember?
That should be a reflection.
You multiply the lengths and you add the angles.
Oh, with like, okay.
Right?
Oh,
Not what we do with vectors.
okay.
There are two, there are two common things we do with vector multiplication. Sorry, this sometimes happens to me. See if I get my voice back. The second way we will learn once you have three-dimensional vectors. The first one works in 2 dimensions. What we're going to do is this, the scalar product, aka the dot product.
Is that not what he said?
That's what I said, sir.
I know, but you just read it off there because that's what it says.
No, that was in my brain, sir.
A dot B is the length of A times the length of B times the cosine of the angle between them.
Why?
That is the definition of the dot product.
But why?
Do we need to prove that?
Because it works.
We
It
need
that
it
helps
to work.
because it does useful things for us.
Why have we got cosine in there?
Because I need to account for the angle. Think about what they're saying. When the two vectors are close to the same angle, this is a small number. So cos is 1. Remember, your cos starts at 1 and goes down. Right? So if the two vectors start pointing the same way, the dot product is just the length times the length. It's like a normal multiplication. But if they get a bit further apart, the product is going to be a bit less. Cos decreases. If they're at 90 degrees, what's cos 90?
1. I mean, so 0.
Think before you call out an answer and give other people time to think too.
0.
The cosine of 90 degrees is 0. If they're at right angles, they have no dot product. Well, they have a dot product, it's 0. If it goes past that, cos is actually going to be negative. So if they're going in opposite directions, I'm going to get a negative product. Same sort of direction, positive product. Opposite kind of direction, negative product. That's what this is doing for me. Let me give you some examples.
Can you prove that?
I don't need to prove it, I'm just explaining what this does.
Yeah, I know, but like, can't you do like some funny background theory? It's kind of just like you just.
I'm giving you an operation that allows you to multiply vectors. Later on, I'll give you a second operation you can do to multiply vectors. That'll be next term.
Mm-hmm.
This operation is called the dot product. Notice, this is a length, this is a length, this is a number. What I've got out of this multiplication is a scalar, not a vector. Important. I'm going to say this several times. On your first exam, When I ask you for the dot product, do not give me a vector answer. Don't be the student who does. Suppose I tell you, for example, I want you to get the cross product of A. Suppose I tell you A has length 5, let me go, length 5, and this vector has length 9, and the angle between them is 40 degrees. Then I just go, A dot B is 5 times 9 times cos 40 degrees. Just apply the rule. You're definitely going to calculate because 40 degrees is not a nice number. I don't care about the number.
34.47.
How much?
34.47.
It's a number. It's a scalar. It's not a vector. I got two vectors. I found a dot product. It's a scalar product. The other way we're going to learn to multiply them later is called the vector product or the cross product. We're going to write a cross, the normal time sign. It gives us a vector. This one, the dot product, gives us a scalar.
So what is that number like on like with the diagram? Like what is 34.47 relating to?
It's related to the length and the angle between them.
Like what does it give
Can you visualize it?
You're visualising. No, it's a number.
So it's just okay.
So what does it give me then?
Well, what if I give you a couple more? Suppose I give you 5 and 9 and the angle between them is 80 degrees. What are you going to get?
$7.81.
Is that what you got? What's happened?
Smaller.
That other people think.
Sorry.
The angle is because of the
Okay.
scalars.
So the closer they are in angle, the closer they are in direction, the bigger this number is.
Wait, how's it a scalar if there's length and like direction?
It accounts for the direction, but the result is does not have a direction.
Okay.
This is not a direction, this is just a length. Let me give you an application now. In physics, have you done work done yet?
Yeah. Kind of.
FS.
Yeah, we have.
Okay, so work done is actually force, remember, is a vector, displacement is a vector. It's force times the displacement in the direction of the force. It depends on the force you apply, but also the direction it moves. If it moves in exactly the same way you push it, you get maximum work. But if I'm pushing this way and it moves that way, I'm only doing some of that work. So my work done is smaller because the angle gets closer to 90. What happens if this angle is 5, yeah, it'll do, 9, and this angle is 120 degrees? Maybe I'll do 100. Yeah, 120 will do. Then what's my dot product? Times 9 times cos 120 degrees.
Negative 22.5.
Negative
22.
22. What happened? 0.5?
Yeah.
Yeah. It should be 0.5. It went negative.
Yeah.
Because these vectors are now pointing away from each other. Similar direction, positive dot product. Opposite direction, negative dot product.
So where's 0?
Where is cos of an angle 0?
So when it's 90, it's 0.
Which means we now have a test for whether two vectors are perpendicular to each other. Okay? Where's my eraser gone? To check whether, well, that's much blacker. Two vectors are perpendicular, to check whether two vectors are perpendicular to each other. Okay, A dot B has to equal 0 if they're perpendicular. So, for example, do I have to make my own up? Really? Here we go. Oh, that's just going to be e.g. e.g. Are these vectors perpendicular? Oh, no, before I can do that, I need to give you one more thing first. Wait, before I can do that.
Bro, I just wrote it.
I know. I'm going to come back to that. Because we don't have it in component form yet. So far I've given you polar form. I've given you lengths and an angle between them. But what if I give you 32.71? Or if you prefer, 3i hat plus 2j hat dot 7i hat plus j hat.
Do you have to convert it first?
Do you?
I'd assume so.
Turns out you don't. Turns out you don't.
Is it just
Can I show you why this other rule works? Yes, so leave a space. I'm going to come back to that because maybe I can just show you. Maybe I can just show you actually. Let's just do this. This is what happens if I am expanding. I'm going to go 3i hat dot 7i hat plus 3i hat plus, dot j hat plus 2j hat dot 7i hat plus 2j hat dot j hat. Not a very clear dot. Here's the thing. What's I hat dot I hat?
I hat squared.
Mod I hat. What's the angle between these two vectors?
1.
Shh. Stop calling out quickly. You're not even thinking. Okay? You're just randomly guessing a number. Right? Actually think about the question and don't answer it.
I did think.
You're wrong.
Am I?
Yes.
Okay, well,
Stop.
I was just going to take my thought process.
Shh. But other people think first. What is the angle between these two? Alright, why do you think it's 1?
Because they're both the same angle, because they're both I.
So if they're at the same direction, what's the angle between them?
1?
What do you think it is? 0.
Oh.
0.
I had the right thought process.
So what's cos 0? 1.
Oh, that's why I say 1.
Okay? And wait a minute, what's I hat dot j hat? What can you tell me about I hat and j hat? I hat, j hat. What's the angle between them?
90.
What's cos 90?
0.
Are they perpendicular?
Yes.
Okay, so I hat dot j hat goes away.
Even with the numbers.
Yeah, I hat dot j hat is 0.
Oh yeah.
So the I hat dot I hat is 1, so I've just got 21. And 2 times 1 is 2. That's 23.
I will definitely come back to this video.
Wait, so how are we...
It's a number, not a vector.
To solve this, do we have to expand and remove it, or are we just multiplying?
Where did 21 come from?
Oh, wait, can I guess? Yeah, 3 times 7.
Where did 2 come from?
2 times 1.
Right? This works in general. A, B, let's do it this way. AB dot CD is, if you want, AI hat plus BJ hat dot CI hat plus DJ hat, which is AI hat dot CI hat. Wow, you're right, Ben. My C's and I's really do look alike, don't they? CI hat plus AI hat dot DJ hat plus BJ hat dot CI hat plus BI hat dot, no, J, plus DJ hat cross cross is AC plus BD.
Yep.
You can go straight from this to that. And if you look at the formula sheet, it has these formulas. Ryan, I think yours might even have that one.
Mine has like 3 of them.
Yeah, good. There's a 3-dimensional one as well. Yes?
I think I'm looking.
Okay. So this says this times this plus this times this. So we can go straight there. And we can go, they're not even going to tell us that. Yes, they are. Good, good, good. Try this one for me. 2i hat plus 5j hat dot negative 3i hat plus 4j hat. And you don't have to turn it into polar form first, you can just multiply components.
So what about a calculator?
You don't need one for this.
You don't register.
What's 2 times 3? What's 5 times 4? Negative 6 plus 20. It's a number. The dot product is a number. It's a scalar. It is not a vector.
Wait, that was so much faster than what we just did.
Yes, because I skipped all the steps in between.
Yeah.
Because you can just go straight to this.
So you just take the first 2 i's and then the second 2 j's.
Huh?
Oh, okay, cool.
And when we get to 3 dimensions, you're just going to multiply the i's, multiply the j's, multiply the k's, add them up. All you have to do.